Hi, this is Lauren Poor, and I'm going over my Week 7 Gauntlet project for SLM Training. The concept behind this particular training is that if we are going to have an SLM trained on data that is difficult for an LLM to understand, what I was looking at was a factory that has redundant sensors on various types of equipment so that if those two sensor channels corroborate on any kind of failures, then we can alert an operator on how to change or repair something that happens to be failing, or if there is a mismatch, what that mismatch might indicate. So what we're looking at here is the quick overview of the network that goes into this training this model, including the repo, the use of Colab for QLoRa, and the Hugging Face hub. What I have chosen for the frontier model is Opus, that acts as the teacher. The Haiku acts as the judge, and the student is Quen 3-17B. And so I created a small smoke test, which was 38 cases, which will then be expanded for later submissions into over 2,500 cases. That's already been generated, but for the purposes of the MVP, I ran a smoke test, and I can demonstrate all of that. We have the deployment topology here, and we're looking at the scenarios that go into the eval prompt, and we see that the Opus and Haiku give us our prompt ceiling with the training data here. I've cloned the GitLab, and we're looking at the training using QLoRa and push to Hugging Face, and then the results are provided. I've added some options here just to show some considerations that went into this architecture. So now what I'd like to do is go over a couple of things. So in our code repo here, we have a summary of our prompt ceiling evidence. The harness and the prompt calling evidence. We have our quick Colab QLoRa path. This is just for the MVP. We have our training repository here, and you can see that it's very small. Again, this is for our smoke test, so it's for the initial run. The larger run will take place after the MVP is submitted. I have also created a large training file here. Obviously, it's too large to display, but again, I've created something with over 2,500 rows so that we can run the larger training test. Here's our Hugging Face repository and the quick Python code for the smoke test and the data that results from the smoke test. I realize that's a little difficult to read, so I created a quick thin client to review the data that I've created. So what we have is a few cases here. We see the Quen before the training, which it adds a little extra detail here because it's taking in the data that we are aware of in addition to the two independent sensors to evaluate what's going on with a particular centrifugal pump. It does break the rule because it walked past a two-sensor failure because it's looking at the current. So it's considered that maybe the current is giving us a false read. But because we have the two failures here, and after training, the diagnosis is changed, so the rule is held and the failure is named to the operator. And we have a few more cases here, and HP Motor does the same. And again, we're not looking at another named failure. Name the failure without the two sensors. In this case, we're looking at the rule held. Instead of naming the failure, we're actually looking at the failure not being held and instead being held to watch, which is our rule. The rule should be that if the sensors disagree, that there should be a watch, but not considered a failure.